So it will take some time. Okay. By the meantime, Anaconda opens. Let me show you how our Excel file or the data sheet file is. Okay. Now this is our data. I hope you are able to see this data sheet. Okay. Somebody please confirm that you can see this Excel sheet. Can you see this Excel sheet? Please write it in the chat box. Yes or no? Yes, you can see. Okay, great. Now see here, this is the data which is available with you. Okay, now again, let me again reiterate this, that you have done this particular multiple linear regression in Excel. Okay, you're going to take the same problem. Okay, I am also going to do the same thing. I am going to consider one particular problem which I had solved it for regression. Okay, now this particular multiple regression data, it consists of basically cement, blast furnace, water, superplasticizer, coarse aggregate, fine aggregate, and age as my input parameters. Okay, and this strength in MPa is my output parameter. Okay, so strength is equal to, okay, x1 into cement plus x2 into blast furnace slag plus x3 into water, so on and so forth. This is going to be the equation which I am supposed to get. And what is my basic objective of doing the regression? The basic objective is to get the relevant coefficients. Okay. So first thing first, what we have to do is, this is my Excel sheet. What I have to do is I have to save this Excel sheet as in CSV format. Okay. That is comma separated format. How to do that? Just check out here. Okay. You write this data in Excel. In your case, the write in the sense you can copy the data in Excel. Okay. Go to file. Okay. Then save as. Okay. In wherever your folder is, wherever your you have saved your files, you can go to that folder, give the name, and you can just see here, save as type. Please pay attention to the cursor. Okay. Save as type. Okay. So as you go down here, you can see CSV, comma, delimited or comma separated. Okay. So you can just click that and just say save. Okay. Now here it's already existing. So it's asking, I'll replace it. That's it. Okay. So now you have saved this file as CSV in CSV format. Okay. This is the first thing which you have to do. Okay. Now let us close this. Okay, we close this all, and this is my Anaconda which is open. I'll go to Jupyter. I'll launch my Jupyter notebook. Okay. It will take some time, so let's wait here. Okay. Now once you see this, go to the particular folder in which you are going to save or you are going to work. Okay. In my case, my folder is on desktop in the folder named DA Python. Okay, so I'll click that, and here you can, as we had also explained this earlier, you can go to new. Please pay attention to the cursor. Okay, on the cursor is now on the right hand side. You can go to new. Okay, and you can say Python 3. Okay, so a new notebook will open. Okay, and you can start writing your code over there. Okay. But on the other hand, now here I have already done this. So my file is already ready here. So I'll open that file so that I can explain it to you. Okay. So this is my file which is ready. Okay. Now I will explain this. Now this particular file, I have written it quite elaborately again. The reason being we should understand what the particular data is. And so I've done that. Okay, you can finish this particular activity of multiple linear regression in just 2 or 3 lines also. Okay, but initially when you actually start doing some coding, it is better that you do it elaborately, so that if you go wrong anywhere, you can it will become easy for you to rectify and to understand. Okay? Now, the first thing first, importing the libraries. So please pay attention to the cursor. Importing the libraries, we have also seen this earlier, that there are libraries like NumPy, Pandas, which are required for numerical computations. So we are going to import those. Now import matplotlib.pyplot as PLT. Now this is a particular library which is specifically used for plotting. Okay, because we are going to plot the scatter plot. Okay, so you require this. Now one more important library here is sklearn. Okay. Now what is this sklearn? Now this sklearn is nothing but a particular library which is available, in which the basic operations related to regression or related to any machine learning models is already available with you. So these are ready-made libraries in which the regression activity can be done automatically. I mean, it is not automatically, it is done at the back end. You don't have to write a separate code for that. Okay, so everything is written in sklearn library. You have to just call those functions. Okay, vis-a-vis to now you have done mean, median, and mode. Okay, there also, if you refer to my session, you will understand that mean का जो हमने किया था वो काफी elaborate किया था. Okay, everything, all the equations, we have done it ourselves. But for median, we used a direct command. Not that direct command which we used for median, it had come from statistics statistics library. Okay, so you don't have to do anything there. Just use the command and you will get the median. In the similar fashion, for multiple linear regression also, sklearn is one of the library in which all the backend operations are available. Now the question comes, is this the only library? Well, no. This is one of the library in which linear regression or multiple linear regression can be done. In similar ways, you have many more also. Whichever is suitable, you can use, but this is the one which I could see is prominently being used. And so we have used sklearn. Okay. Now here, what we have to import from sklearn, you have to import the data sets. Well, this particular command of importing data sets is that if you are going to use some ready-made data sets, then only this particular import data sets will be important for us. But in our case, we are having our own data set. So importing data set will as such not be of any use for us. But from sklearn, this linear model, okay, that is your linear regression model, this we have to pick up, and metrics. Okay, because you need to understand how much is correlation between the actual or the observed value and the predicted value. And so for that, metrics is required. Okay, so we are going to take this from sklearn. Okay. Now the second one is, you are going to this import pandas, अभी ये थोड़ा सा double हो गया है, you can ignore it. Okay. Now I'm going to give a name of my data set. I'm going to read my data set. So data set is equal to PD. Now what is PD? PD comes from pandas, in which you're going to have a data frame. Okay, data frame also we have already explained it to you in the earlier videos. Okay. Now PD.read _ CSV. Now this is a command which is used to read your data, which is in CSV format. You remember we had saved our data in CSV format. Okay. So now what is the name of your data set? It is regression-all-data.csv. Okay. Now this is my name of my file. You can give any name you want. This is the name which I had given. Okay. And .csv is the format. Okay. Now print into bracket data set dot columns. Now what this particular command will do? This command will print all the headers of your data file. Okay, so when I actually run this, okay, you can see it is showing me cement, blast furnace, slag, water. Okay, now this, why we are doing this? Just to make sure that the data has been read by Python properly. Okay, maybe this is, again, as I said, this is required at the initial phase. At the later phase, probably this is not required because you will get used to this. Okay. Now comes the next command. Next command is print into bracket, into column, bracket and colon, the shape of our feature is. Okay, just to understand how much is your data set. So the data set dot shape, this is actually your command. Okay, shape means what is your, how many rows and how many columns, which is also called as features. Okay, so the shape, so when you run this, how are you going to run? Go to this particular row and just click on run. Okay, you can run this out. Okay, so the shape of feature is 129, 8. So you have 8 columns and you have 129 rows of your data set. So our data is being read correctly by our Python. Okay, so that is what assurance this particular command will give us. Okay. Now next, let us start reading the data. Okay, now let us start segregating the data into input and output. Okay, now how much are input parameters? 8 input parameters. Okay, now one of the characteristic of Python is that the first column is supposed to be 0. So it will be 0, 1, 2, 3, 4, 5, 6, 7. So total 8 columns. Okay, so if you see this particular video, if you're looking at this particular video, you can see I've given the meaning of each of the line as well. Okay, so now let us see. X is equal to data set. Data set means what? From, it is coming from here. I've read my data as a name data set. Dot iloc into bracket colon comma 0 colon 7 bracket closed. Now what does this mean? This means read X, okay, as data set iloc. This is the command to read your data column wise, okay, from 0 to 7. Okay, so we have 8 columns totally in our CSV format. The first column is by default is the 0th column. Okay, then the first column, second column, so on and so forth. So from 0 to 7, read the data as X. That is what is the meaning of this command data set iloc. Okay, and when I give only X, it means that it is going to display that particular data. Okay, now display this X data. So you can see here 1, 2, 3, 4, 5, 6, 7. 7 तिथे 8 होते का 7 होते? Maybe 7च असतील. Check out. Just 1 minute. Let me check out. Two, 3, 4, 5, 6, 7. Yeah, it is 7. So this will be 1, 2, 3, 4, 5, 6, 7. Okay, so that is correct. So cement, blast furnace slag, water, superplasticizer, coarse aggregate, fine aggregate, and H. Okay. So it is 0 to 7. So 0, it will be this particular column, which is giving 0, 1, 2, 3, 4, 5, etc. Now coming to the next, now we have read our X data. That is what is input data. Okay. Now let us read our output data. Output data means what? Now we will give it a name Y. Okay. So Y is equal to data set that iloc. Now here it will be colon comma -1 colon. Now what is this -1? This -1 is nothing but the last column of your sheet. So which is the last column of your sheet? The last column of your Excel sheet or your CSV sheet was strength, which is our output. Okay. And so you can give by default, if you have only one column as your output, the last column as your output, you can by default give it as -1. Okay. So that will become your output column. Okay. So just display Y and you can see the strength data seen here. Okay. So now your input data has gone as X, your output data has gone as Y, and it is displayed also correctly. Okay. Now this Y test, Y underscore test. Now this I have basically given to see which is the testing data. Okay. Now we are going to use the whole data for our model development. Okay. So we have given the whole data. This is just extra which I have actually been used here. Okay, fine. I have not divided the data here into training and testing. You don't know that particular concept right now. So I've used the whole data. Okay, So this is just an extra command. If you don't use this command also, y_test, it is okay, no problem. Okay. Now, coming to our actual work now here is from sklearn.linear model, import linear regression. We have used this particular library. I mean, calling this particular library in the first column also. I've done it again. If you don't do it here also, it is okay, not a problem. Okay. So from sklearn.linear model, import linear regression. Okay. So you're actually calling the ready-made library from sklearn. Okay. Now what you have to do is you have to fit the linear model. Okay. Fit the linear model means you want to predict y values using the x values. X is input, y is output. So what will the command? The command will be model is equal to, now this is a name which I have given, so you can give any other name also. Model is equal to linear_model dot linear regression. Okay, this is what is your actual command for linear regression, which you are importing it from sklearn. Okay. Dot fit. What is fit? Means fit the data of x to predict y. Okay, so fit x and y dot values dot travel. Okay, now this numpy dot travel, this is actually the functions return contiguous flattened array, because this whole data will be in the form of matrix, is it not? So you require this particular command. Okay, now what we are doing here, you are taking the value of x, you are trying to fit the x value. Okay, x values, not value, values. That is what is your input values, and you're going to predict your y values. But for doing that, you first want to have the coefficients. Okay, so coefficient fixation is actually the major task of linear regression. Okay, for this, your data is input x, your output is y. So you're going to try to fit that using the command linear_model dot linear regression. आता याच्यामध्ये होतं काय, तर if you people remember multiple linear regression we have done, in which depending upon the number of input parameters which you have, a number of parameters you have, what we call them as independent parameters. Input parameters means what we call it as independent parameters, and y as your dependent parameter. Okay, so independent parameter, depending upon the number of independent parameters, you will have number of equations which simultaneously you need to solve. Okay, now when you solve this particular equations, you get the coefficients. Okay, which will help